Hi, this is Fazana again. Welcome to another new topic on the Fazmaths channel. In part 1, we'll look at the actual circle theorems you need to know, and I'll hopefully make it easier for you to remember them with some useful tips. And then in part 2 onwards, we'll tackle the questions like a pro. Let's have a look. Okay, first and probably the simplest circle theorem is tangent meets radius at 90 degrees. Yeah, so that's 90 there, that's 90 there. All right, yeah, and you know your radius is just from the center of the circle to any point on the circumference. Yeah, all right. Tangent actually means touching in Latin, as in tango. Yeah, so the tangent meets the radius. Yeah, okay. Second one is angle extended by diameter is 90 degrees. Yeah, okay, so even if you had something like that, whoa, that would be 90 degrees. Yeah, if you had something like that. So any angle extended by the diameter is 90 degrees. Okay. The third one, angle at the center is twice the angle at the circumference. All right, yeah. This one is the angle extended by diameter. If you can see, that angle is 180 degrees, yeah, and its still angle at the center is twice the angle at the circumference. Yeah, so that's just an extension of that. Yeah, all right. Next, angles in the same segment or extended by the same arc. I like the extended by the same arc because it tends to make more sense to me. Yeah, so that has been extended by that arc, and that has been extended by that arc. Yeah, so those two angles are the same. Okay, and then of course it follows that those two angles will be the same because they've been extended by that arc. Yeah, and then of course because these two angles are vertically opposite, they'll also be equal. All right, okay, remember the center here has nothing to do with the actual question. So when we have the angle at the center is twice the angle at the circumference, when you have a question diagram like that, and that's the center, and everybody sees the bow tie, they always think these two angles are the same, but they're not actually, because this one is angle at the center is twice the angle at the circumference. Okay, so this one's a really good question to trick you with. Okay, so beware of this one. Yeah, all right. Cool. Okay, opposite angles in a cyclic quadrilateral add up to 180. A cyclic quadrilateral is a quadrilateral where each point actually touches the circumference. Yeah, so it has to touch the circumference. Okay, and then that plus that will equal to 180, and so will that and that angle. All right, yeah, good. Here, two tangents meeting at a point are equal in length. Okay, so you can tell if the triangle's drawn that way, that makes that an isosceles triangle. Yeah, all right. Let's just make that 40, and you get these two congruent triangles there. Okay, so let's make that whole angle 40. So of course that'll be 20 and that'll be 20. And then radius meets tangent, radius meets tangent. Yeah, and because it's a quadrilateral, the angles will add up to 360. So if those two come to 100, oh sorry, if those two angles add up to 180, then you know these two will always add up to 180. Yeah, so that's a good tip to know. Yeah, okay, and because this triangle is isosceles, you can tell that one's going to be 180 minus 40 is 140, and then half, so those will be 70. Because that's a right angle, these angles will be 20. Okay, so whichever angle you're actually asked for, can you tell it all sort of follows? Yeah, and you can tell that's an isosceles triangle because you've marked your radii. Yeah, as important as it is to know your circle theorems, you've always got to mark your radii, because as soon as you mark your radii, you get isosceles triangles. Yeah, okay. So if you don't mark your radii, your workings on circle theorems will just flop. All right, good. Okay, the angle between the tangent and the chord is equal to the angle in the alternate segment. Yeah, we look at this one where, remember we said angle extended by diameter is 90 degrees, so that will be 90. That will be 90 as well, because radius meets tangent. So if that is 50, yeah, just that bit there, then you know that bit will be 40. Okay, and angles in a triangle come to 180, so if that's 90, those two will be 90, so that will be 50. Yeah, so can you see the angle between the tangent and the chord is equal to the angle in the alternate segment? Yeah, all right. I sort of look at it like opposite. Yeah, all right. Okay, so on the same basis, the angle between the tangent and the chord, which will be x, will be equal to the angle opposite there in the alternate segment. Yeah, so on the same basis, that angle y will be that angle y. And then if we just put a z there, we can tell x plus y plus z comes to 180, and x plus y plus z comes to 180, angles on a straight line. All right, yeah. Okay, and as I mentioned before, always mark your radii. Yeah, all right. And that just makes all these triangles isosceles. Yeah, so if you had that there, that becomes isosceles. Yeah, life is just full of radii. All right. Okay, so those are the only circle theorems you need to know. They're not that many, actually. I think people just sort of tend to look at all these circles and get really confused about, oh my god, there are just so many. Yeah, so we'll just run through them again. Tangent meets radius at 90 degrees. Can you see I've sort of given up using the, yeah, it just makes it too long. So I don't say the tangent meets the radius at 90 degrees, just tangent meets radius at 90 degrees. Angle extended by diameter is 90. Angle at center is twice angle at circumference. Angles in the same segment, let's just number them. Angles in the same segment or extended by the same arc are equal. Opposite angles in a cyclic quadrilateral add up to 180. Two tangents meeting at a point are equal in length. And the angle between the tangent and chord is equal to the angle in the alternate segment. Yeah? And then, of course, importantly, mark your radii. All right. Okay. Good. That's all for now. Now join me in part 2 to work through some really interesting questions. Once you've been through all the parts in my circle theorem videos, I guarantee that any question you get in your exams you'll be able to handle, because I've collected some really interesting questions and a real variety of them. Yeah? And there's always a circle theorem question in the exams, so once you've worked through all of them, you'll find the question simple, trust me. Yeah? You won't be going around in circles. Okay, remember, you're in control. Take care. Until next time. Bye.